Greetings, welcome to the Evidence Reasons Academy. Glory and honor to our Lord and Savior Jesus Christ. Congratulations to the Houston Astros winning Game 6 of the World Series and the entire series. So they are crowned the world champions. Congratulations to Dusty Baker, 73-year-old manager, finally winning the World Series after waiting a long time. So little bit of news. I like both teams, the Phillies and the Astros. It's sad one team has to lose. So not that I particularly had a favorite, but I'm happy for one of them, one of the teams, because of the manager, Dusty Baker. So on to the matters at hand. I have talked about the Michelson Moreley experiment that established, when combined with Maxwell's equations that had been written, had been kind of codified about 20 years earlier, before the experiment. When you combine that little oil lamp experiment motivated Hendrik Lorentz to create his Lorentz transformations, to combine it with Maxwell's equations, and that predicted that the faster you go, the slower you age. It has been interpreted that by Einstein that time is relative, and in the modern day it's becoming accepted to say Einstein was not quite right. General relativity can't be quite right because quantum mechanics wants absolute time. There has to be an absolute clock. And so there has been a conflict. This is known. Oh, Damian Martinez, God bless you. Let me say hi to you. Let me see if I can. 1 second. Oh, Damian Martinez, God bless you. So hang on. And you're an inspiration, sir. I'm going to promote you to moderator. So thank you for your encouragement, brother. Glory and honor to our Lord and Savior. So the reason this is important, and Mark O'Connell, greetings, is that the Michelson-Morley experiment has been widely interpreted in the popular day, understandably, to say that there was no ether detected. It doesn't mean that the ether didn't exist. They couldn't detect it unequivocally. Lorentz postulated the ether still exists, added the Lorentz transformation. At least this is my understanding. Anyone's welcome to correct me if I'm wrong. Lorentz added that ether, the transformation, to account for the ether not being detected, and it led to time. It led to the phenomenon that the faster you go, the slower you age. Einstein took it upon himself to say that time flows differently, but as I said, that is not consistent with quantum mechanics. It's now said that that because of quantum mechanics, which most physicists will say takes precedence over other laws, accepted laws of physics or principles of physics, that Einstein's general relativity can't be quite right. Also, I've read that the phenomenon predicted by quantum mechanics of the zero-point energy has brought a return of the ether. The Wikipedia article says, well, it's not really kind of the ether that Lorentz was envisioning because it wouldn't have Lorentz invariance, and I would have to contest that. And I tried to do a little derivation this afternoon and also show you the principles why. One of the things that I showed was I said hypothetically, let me see if I could show it here. Hypothetically, if you had one spacecraft that had a precise clock, so let's say we had two spacecrafts at an airport, and again, this is a hypothetical example, it's very similar to the Hefel-Keating experiment, but let's just do a thought experiment here. The Hefel-Keating experiment actually, one can claim that it actually illustrated this, but the airplanes were really not quite fast enough to do what I'm trying to show here. But let's say you had two airplanes on the airport. You had 3 atomic clocks, cesium beam clocks. You could put them on, you can synchronize them here at the airfield. You have one airplane get up to a speed of 99% of the speed of light going one direction, and the other going 99% of the speed of light in the other. What would you say is the clock rate? What would be the registered clock rate in each of these? And I would argue that it's likely that minus just slight differences, and I'll explain what those slight differences are, that the airplanes would have the same clock rate. This is inconsistent with the fact that obviously, even from his reference frame, this guy is moving very, very fast, and yet he has the same clock rate. That would suggest, if this happened, this would suggest then there is an absolute rest frame, and you could slow this guy down. You can get him to turn around and accelerate the other direction, and once he gets down to the speed of here, the control tower, then his clock is ticking at the rate of the control tower, and this guy is ticking at that slowed rate by a factor of 7. And you can find this out. You just go to the Hyperphysics website, and you can actually punch this in. If you're going 99% of the speed of light, the clock here will slow down by a factor of 7. And you're like, well, that shouldn't, that seems kind of odd. That he's going to keep accelerating, and as he's accelerating, his clock starts to speed up, and then it starts to slow down. Like let's say he turns around and he leaves one of his clocks behind, like that. So let him carry 2 clocks. So the clock out here that keeps moving, his clock will actually start to tick faster than the clock he left behind. I'm going to modify this some more. And this would suggest there is an ether, just like Lorentz claimed. And I had agonized over this, and Damian Martinez was my inspiration, gift of God, to help me get through this derivation as I was studying these equations that predicted. I did the derivation that many had done prior to me. I'm not taking credit for this insight, but I had to learn to do the derivation on my own, and that was kind of painful over the last 6 weeks. But then I began to have insights as I was thinking about what that derivation meant and why my professor had me do it, had all the students do it the first day of class at Johns Hopkins, at the Introduction to Modern Physics class at Johns Hopkins. I was wondering why. So this has implications for young Earth creationism, because if there's an ether, and the ether's properties can be different in locations in space over time, then the speed of light could be variable. The speed of light may not actually be absolute. And this opens up a lot of possibilities, guys, and could resolve paradoxes of what we're seeing when we're making observations in the deep space. It's becoming painfully evident that what the James Webb Telescope is seeing, a lot of astronomers are not happy. They began saying had to rethink about everything, and some people are really going one step further and saying that the Big Bang could be wrong. So this is an exciting time if you're a young Earth creationist to be alive, because things that seemed immutable and inviolable, and no way that young Earth creationism could be right, it's starting to change. I'm not saying that the doors have swung open, but we got that little break that we might need. first with the Big Bang, and then now with variable speed of light, the possibility of variable speed of light. And I knew I was an old Earth creation. I was a theistic evolutionist, then a old Earth creationist for most of my life, and then I became a young Earth creationist when I began to hear the secular world think about variable speed of light. This, now that so Mark here said he'll take a pass on the differential calculus here. This was really for my benefit and also to show the rest of the YouTube community and the world. I'm willing to slug through the math. You can't accuse me of not really exerting effort to understand this. So this is also for me, and also for me to be able to interact with scientists like Philip Dennis, who's generously offered to retutor me in general and special relativity. This is my way of kind of asserting to him that I'm eager to learn. Hopefully I can demonstrate that I'm worth his time by making that derivation, and then maybe we could look at all this kind of with just a different look. He is a respected secular physicist who has worked on who's a consultant to NASA on general relativity, and I've seen some of his papers that were published in a mainstream secular journal, and yet he's also a young Earth creationist. He's the right person I need to be my mentor. So my mentor in biology was Dr. John C. Sanford and Dr. Joe DeWeese. I've had the privilege of publishing with both of these individuals, but really my heart, I'm an engineer and a student of physics, not really biology. Most people know me as a biology guy. I'm really not. This is more my native element. So I wanted to work on the distant starlight problem and cosmology. So this is a kind of returning to my roots, and maybe before the Lord takes me home, I'll be able to make some sort of contribution to young Earth creationism in the area of physics. And I'm excited that I might have the chance to work with Philip Dennis. I'm looking forward, I've had the chance to learn a little bit from Russell Humphreys on Maxwell's equations and the geomagnetic field, Cowling's theorem that the Earth is young. I mean, this is really good cutting edge young Earth creationism that you just don't hear about. So I'm excited. So today it's going to be a kind of a torturous session where I talk about the Michelson Moreley experiment. Was said to not have detected the ether, and people are saying it didn't exist. Well, there's a difference between not detecting it and saying it didn't exist. Okay, there's a slight difference. The fact that they didn't detect it, again, you can still have a special relativity theory that still has the ether in it. Even Einstein said that. But Einstein said, well, maybe it could exist, but we're not able to detect it. Fine. But, Lorentz had his idea of special relativity is still based on the ether, and it's very compatible. Now that I work through the equations, I can totally see it now. And even more so after I did this today, where I just took basic textbook special relativity and I said, it's obvious there's an ether. You can still have special relativity with an ether. How do our clocks somehow know that this guy had experienced so much acceleration and got to that velocity? It would be the prevailing idea among the neo-Lorentzians like myself is that it's not exact. This is a very approximate illustration. If you're on a motorcycle or something and the wind's blowing on your face, or you're in an open cockpit when you're flying, the faster you go, you could feel the wind hit you harder and harder. We call that dynamic pressure. Well, if the ether exists as you're traveling through the medium, it's the system, the object is actually experiencing the ether now kind of hitting it harder, and it's slowing down its clocks. And so it's not that time flows differently, but motion through the ether slows down the clocks. That's believable. Anything can slow down the clocks down to the all the processes just get sluggish, gets a little slower. And like what ends up happening when you're experiencing dynamic pressure, you're getting you're seeing a lot more molecules or something. So the idea is the clocks slow down when you're experiencing more of the ether. If the density of the ether is lighter in some places, all the clocks speed up, and also the speed of light can move faster. And there's a paper worth reading on this channel that talks about an experiment that may confirm if you have Casimir plates and you start to change the density of the ether between the Casimir plates, you should be able to detect an increase in the speed of light. That would be a very, very, very interesting experiment to carry out. I don't know how it can be done, but that would be totally interesting. So, and then to the thing about the Michelson Moreley experiment, most of the Michelson Moreley experiments were done in vacuum. The Michelson Moreley experiment was done with air as a medium. Air has a refractive index. If you've ever seen the mirage out in the, on a hot day and kind of like a desert land, looks like water or something out there, like a lake. That's because the light can be bent by the air. Of course, the different densities of the air because of the temperature can cause that mirage. But you have a refractive media. So when you wear glasses, the glasses refract the light, and so the glass really refracts light. Water refracts light. All sorts of substances. Air, not so much, but it still does it a little bit. The air in the original Michelson Morley experiment, they did show a little bit of a detection there. Some people have gone back and re-examined the numbers and said, oh my goodness, it looks like he did detect the ether. You just had to use a certain kind of math and you'd actually see it. Had to revise the assumptions that Michelson and Morley were using. Their math had a mistake in it. If you corrected it, you'd see that they actually detected it with air. So this motivated trying to do Michelson Morley experiments with different refractive media. And I'm going to cover V.V. Demjanov's paper on this. Now, that being said, some people obviously were very upset with his paper being accepted for peer review. The editor-in-chief retracted it, but then it seems that Demjanov has still stood by his claims. His paper was in the archives, thank God, the Cornell archive. And so it was accepted in 2009. Somewhere it got retracted, but then Demjanov had it published in archive in 2018, which I'm extremely grateful for. And it describes the saga of him rebuilding the Michelson Morley interferometer and the construction of it and the results in a refractive media. Okay, so thanks for your comment, Mark. And there's still a lot I don't know, so I don't have any comment at this time. I'm still learning. So I'm just gonna slug through not the entire paper, but maybe the highlights. So let's see. Let's see here. This was the retracted paper. Now he's obviously not an American, so he doesn't speak. His English is a little off, but it's mostly readable. So this was, see now, it was dated October 31st, 2018, which, so this is kind of the re-entry of this into the public sphere, probably after it got retracted. Physical interpretation of the friendship measured on Michelson interferometer in optical media. The shift of the interference fringe in the Michelson interferometer is absent when arms light carriers are vacuum, but present in measurements where the refractive index N of its light carrying media N is greater than 1. So just a comment here, air has a refractive index greater than 1. So if it's a vacuum, it's assigned arbitrarily 1, and if it is, something like air or glass, it'll have an index greater than 1. This experimental observation induced me to interpret physical processes occurred in the Michelson interferometer in a conceptually new way. I rejected the classical rule C prime equals C plus V of adding velocity on an inertial source of the interferometer with the velocity C of the light emitted by it as inapplicable in principle to non-inertial objects which electromagnetic waves just belong to, and not taking into account N of the optical medium. I used instead this rule, the non-relativistic formula of Fresnel, Cn plus or minus V 1 over N squared for the speed of light in a moving optical media where N is taken into account and the condition C prime is less than C always holds. Okay, this is the Fresnel formula. Let me show it. It's Fresnel drag. Drag. So if we go to the Aether drag hypothesis, so this is what Demjanov is referring to. This formula, the Fresnel drag. And this is kind of important in the formation of the Lorentzian ether relativity, this Fresnel drag term. Okay, so Demjanov puts that formula, so he didn't pull that totally out of the air. It exists somewhere, this Fresnel drag. This formula, and accounting for the physical effect of Lorentz contraction of the longitudinal arm L with a double bar of interferometer because of its motion in the stationary ether, enabled me to construct the theoretical model delta xm is proportional to L delta epsilon times quantity 1 minus delta epsilon. Where delta epsilon is n squared minus 1 is the contribution of particles into the permittivity of light carriers that reproduce the essential features of the parabolic dependence of delta xm on delta epsilon. I'm going to correct the English a little bit, and I'm sorry I didn't show this. Goodness, I totally lost it. So I was talking about the Fresnel drag term. So there's this Fresnel drag term right there that Demjanov is that Demjanov is incorporating this Fresnel drag. So I'm going to read this again because I didn't have it on the screen. I used instead, and I'm going to correct his English a little bit just to help the readability. I used instead of this rule the non-relativistic formula of Fresnel, which is this. For the speed of light in a moving optical medium, where n is taken into account and the condition c prime is less than c always holds. This formula, and accounting for the physical effect of the Lorentz contraction of the longitudinal arm L double bar of the interferometer because of its motion in the stationary ether, this enabled me to construct the theoretical model which he describes here. It's hard to read that formula out and speak it out, where delta epsilon equals n squared minus 1 is the contribution of particles into the permittivity of light carriers that reproduced the essential features the parabolic dependence of delta xm on delta epsilon. From the experimentally measured amplitudes of shifts of the interference fringe, there was estimated the horizontal projection, the velocity of the Earth relative to the ether, the changes in different times of the day and night at the latitude of obninx, within limits of 140 divided by 480 kilometers per second. The fourth version of the report is complemented with the account of the harmful effect of registering the shift delta xm of the interference fringe of the improperly installed turning points of the zigzag light path glass mirrors. The nullifying of the shift in the interferometers may occur because of the opposite signs of the contribution of air and glass optical media through the discovered law, which is here. This may be the cause of obtaining negative results in the majority of Michelson type experiments known to date. Now, I'm going to just say, okay, I'm not saying we should redo the Michelson Moreley experiment. I'm suggesting we do experiments more like this Cahill interferometer, which I'm trying to reconstruct. This might be more stable, I'm hoping. And Cahill has other experiments. I wish I could be in contact with Peter Morris. Maybe someday I'll get to that point. Cahill is a emeritus professor at Flinders University, and I recently had a show that talked about Flinders University. So he's an academic at a respected school. So I kind of don't like all the name calling in academia sometimes. They're calling these guys cranks. I don't like it. Well, maybe I do the same because I think evolutionary biologists are... Well, I won't go there right now. So, this isn't the easiest read, but it does talk about that he was detecting the ether when he used optical media. So let me see if I'm not going to read the whole thing. Because I also, people that are familiar with the Michelson interferometer would absolutely know what this means. But he was using a lot of different optical media. All right, so let's just read a little bit of the history. And, maybe at some point I might study the theory. It says in 1968 through 1974, being a scientific researcher at Obninsk branch of the Karpov Institute of Physical Chemistry and experimenting with the Michelson interferometer, I detected the occurrence of the non-vanishing amplitude of the shift, delta xm not equals 0, of the interference fringe in the air of normal and enhanced pressure that continually vanished in the course of the evacuation of the air from light-carrying regions of the interferometer. I measured delta T for various transparent dielectric materials with the optical dielectric permittivity going from 0, where epsilon is greater than 0 and less than 3.5, that I have managed recently to briefly publish. So he's retelling his measurements on this interferometer. Figure 1 presents more detailed experimental data comparing with those that I have. Figure 1 presents more detailed experimental data comparing with those that I have given in ePrints and archive version 1 and 2. The necessity to refine them, renormalize to common parameters, length L of arms, wavelengths lambda, and a single time of day or night implementing the measurements, was pointed out to me by referees of the manuscript of the article from the journal Physics Letters A. I thoroughly performed such renormalization in Figure 1 of 4, after which the article was accepted for publication in Physics Letters A. So I present below this figure from PLA in a more elaborated form as Figure 1, supplementing it by the curve 2 with more detailed description of it. Because of the brevity of the previous description of my experimental results, I present below the Table 1 containing full primary, non-normalized but directly read off the screen of the kinescope, values of measured amplitude of harmonic shifts delta XM of the interference fringe. These data were obtained at 3 different frequencies of the rays that provided me in the region of the normal dispersion with 6 different values of the dielectric permittivity of light carriers. 3 at water, 3 at fused quartz, the 7th point I obtained at glass heavy flint, and the most highly permeable in my experiments. In comparison, Figure 1 of the article of the Figure 1 given below is supplemented by the curve 2 corresponding to minimal values of the amplitude of the shift of the interferometer fringe in the 24-hour cycle of the day and night, observing the value of delta X M min obtained at the above mentioned 7 permittivities of light carrying media of my interferometer. Okay, this is really, really technical. I have talked to some people that review other experiments, and they said sometimes they have to spend days reading the paper to be able to evaluate what this experiment actually measured, how it was done. It is just brutally difficult. It's desirable that the details are sufficient enough that someone with some expertise in the field can reconstruct the device and rerun the experiment. One thing I really liked about Cahill, his experimental descriptions were so precise I could reconstruct the interferometer. This isn't the full interferometer. This is just the heart that has the laser and the optical wires. I have to connect them to all sorts of measuring devices, and I'd love to start doing that again. I mean, this is what I consider real science. I mean, it is hard, it is detailed, very precise, very different than evolutionary theory. I mean, because they actually have experiments, not speculations pretending to be experimental data. So I'm just going to skip a lot of this. He was showing the effect of optical media on his results, and anyone who wants to go through the pain of building a Michelson interferometer, have at it. I wish I could have some conversations with people about this. It seems to me he has he has enough expertise that I don't think he faked the results. And let's see, there was formula 13 here. This one right here. This formula 13 right there. So he deduced this, and then he says Peter Morris, another researcher, arrived at that formula independently. He said, after the publication of Formula 13, it has been deduced by Peter Morris by other means, from a generalization of the Maxwell-Sellmeier formula onto moving optical media. This once again emphasizes the indispensable role of the corporeal medium with the polarization contribution of delta epsilon in the formation of the law. Okay, so I'm not going to go through all this. Okay. See, it says here, on the Michelson type interferometer, there was obtained for optical media with the refractive index greater than n greater than 1, index greater than 1, n greater than 1, the shift of the interference fringe that enhances considerably the ratio of signal versus noise. The positiveness rather than negativeness of Michelson experiments is thus demonstrated. There was measured the difference of round-trip times between the paths of propagation of light in parallel and transverse direction to the translatory motion of the interferometer. Okay, so there is some assumption that the one reading this is familiar with the actual details of the original Michelson interferometer. So when he's talking about the parallel and transverse paths, someone who studied the Michelson interferometer would understand the meaning of that. I'm kind of fuzzy on it myself. But let's continue. Experimental observations are well described by the theoretical model based on the pre-relativistic appeared to be Lorentz invariant and non-Galilean formula of Fresnel for the drag of light by the moving optical media. Thus, there was shown the inadequacy of the additive rule C plus V for the composition of light speed, C, and the velocity of V of a moving inertial body used by Michelson in deriving the formula. So Michelson's original formula in his non-detection was actually an error, and this is the correction that I think Cahill, Demjanov, and others had put where they add the Fresnel drag computation. And now I'm getting a little more familiar myself with what the Fresnel drag computation is. This is really good. It should be stressed that in terms of the interpretation suggested, which is conceptually different from the standard one, all known measurements on Michelson-type interferometers where the normal air pressure was maintained, that corresponds to almost delta E epsilon, approximately 0.0006, always indicate a delta XM not equal 0, and hence delta T is not equal 0. That is why all experiments reported with normal air pressure, they notice non-zero values delta XM among the noise. But Michelson missed the delta epsilon in his formula, and thus by the noticed trace of delta XM in air-like carriers, he obtained an underestimation of delta E. Okay, 40 times of the absolute speed of the Earth. Okay, his numbers were off. And that this agrees with Cahill's calculation. And so all the mentioned authors obtained instead 200 to 400 kilometers estimations lying in with the bounds of noise, 5 to 10 kilometers per second. Okay, so Michelson may have actually measured the velocity of the Earth rotating and also traveling around the sun. He may have actually measured the ether if he used the right formula when he had air. So this is not very clear, unfortunately. Cahill does a better job of explaining this. So that's it so far. I'm going to point out that, okay, see there it is. Cahill R.T. Cahill and Christy Kiddo, and they wrote this thing, Michelson Moreley Experiments Revisited in Cosmic Background Radiation, the Preferred Frame. So this would be worth reading at some point. So now let's go to, there's this paper, and I don't think I'm necessarily going to read it. It's theoretical. What and how the Michelson interferometer measures. And there's an interesting reference here to Dmitriev. And it is VP Dmitriev. Okay, so Dmitriev is a professor at one of the Moscow State Universities. I'm just going to read Dmitriev's paper because this supports Demjanov's experiment. Absolute motion determined from Michelson-type experiments in optical media. The symmetry of vacuum is characterized by the Lorentz group with the parameter C. Physical space inside the homogeneous optical media should be described by the Lorentz group with the parameter C over N, where N is the refractive index of the medium. Violation of a one-parameter phenomenological symmetry in the discrete medium such as gas creates the opportunity for experimental detecting the motion of the optical medium relative to the luminiferous ether. So the anisotropy of the speed of a wave propagating in the otherwise isotropic medium, the anisotropy of the speed of a wave propagating in the otherwise isotropic medium arises when the medium moves in the laboratory rest frame. We're interested in a case when at least part of the anisotropy is retained in the reference frame moving together with the medium. Okay, this is a little bit thick. There are a number of theories as to what this is describing. Let's just dig a little bit into the math. Maybe we can get some insights. Conditions for the anisotropy of wave speed in a moving medium. The linear, elastic, incompressible medium is governed by the D'Alembert equation. Oh my goodness. So this, you remember I was agonizing over this? This is the D'Alembert equation, and now he's referencing it. This equation here, the D'Alembert equation, Dmitriev is referencing it. And this is just a different way that it can be framed, all right? It's the same equation. I recognize it now, but it doesn't look like the same one, but it is. All right. Where S is the variable displacement and W is the elastic constant of the medium. Omega is the elastic constant of the medium. Equation, okay, so S is the variable displacement and omega the elastic constant of the medium. Omega, okay, so the S could be the S here, this variable displacement, and I wish he didn't use those terms, but that corresponds, the variable displacement would be like the psi here, okay? And I know it doesn't look like the same, it's not the same form, but it's the same equation. It's still the D'Alembertian acting on S. So this is the D'Alembertian acting on S. S is the variable, and omega is the elastic constant of the medium. Equation 1 is Lorentz invariant. Okay, so it says equation 1 is Lorentz invariant, and I demonstrated that with this equation. I demonstrated that his claim right there with all of this. So let a signal move through the medium with velocity u less than w. Assuming that the inertial reference frames are related with each other by the Lorentz transformation, we have the following group transformation of u to the moving with the velocity v reference frame. Taking in v going to v minus and then u going to u with the u prime going to tilde, we have to interpret u tilde as the result of the drag by the signal moving with a velocity v medium. Okay, this is really thick. Okay, guys, I just want to point out right here that that's like one sentence. That one sentence, I had to go through this agony to demonstrate that one sentence. I had to go through all this agony and to affirm that sentence. So this is what is so hard about physics. It is so thick. So that's 40 hours of work for me. Right here, just that first sentence. All of this right here. All right. What's it going to be like to get through all of this? Okay, so he said let a signal move through the medium with a velocity u less than omega. See, I don't know, why would the signal move through the medium with a velocity less than omega? I don't know why that would be. So we have an elastic constant, and then we have a velocity less than omega. Okay, omega is... I don't know why that omega here is the speed of light, and because I know the DL inversion, I know that's the speed of light. I wish I used the term speed of light. Okay. Let a signal move through the medium with a velocity less than the speed of light. Assuming that the inertial frames are related with each other by the Lorentz transformation, we have the following group transformation of u to the moving with a velocity v reference frame. Okay, he's just repeating something that's well known, this Fresnel drag term. I don't like his symbols here. And he does some sort of substitution. Oh boy, this is so hard. I'm sorry, I'm just struggling through this. Okay. Okay, supposedly in a discrete medium such as rarefied gas, we have W equals C, whereas U equals C over N, then UF not equal to U. See, this is so hard to understand. Therefore, the anisotropy of wave propagation in the moving frame together with the medium reference frame may arise provided that this medium represents a small or point-like perturbation of vacuum. You seem to be saying that you can detect motion in the vacuum because you're creating perturbations in it. Let me just read this again. Therefore, the anisotropy of wave propagation in the moving frame together with the medium reference frame may arise provided that this medium represents a small or point-like perturbation of vacuum. It's not very clear. Now we may calculate for omega c and u c over n the difference of waves round trip times in the collinear transverse orientations of the Michelson interferometer. The collinear path can be immediately found. This is not very pleasant to see. This is practically unreadable here. The crucial point in detecting the anisotropy of light propagation in the moving together with the medium laboratory is the validity of the Fresnel drag in the absolute reference frame in ether. In this event, it is important that the Fresnel drag of light obtained from known kinematic relations can be derived independently in optics of moving media. One way or another, the accuracy of the derivation must be higher than v squared over omega squared. This is so hard to read. This is just brutal. And it doesn't help, it's not really nicely described. And they're referring to R.T. Cahill, Keto, Michelson Moreley experiments revisited in the cosmic. I'm going to look this one up, and maybe we'll either do a different show on it, because this paper by Dmitriev is just like unreadable. So let's look at this one by Christy Keto and Reginald Cahill. I think Christy Keto was his graduate student, and she now is a professor of mathematics somewhere, so she's very, very bright. But let's just look at this. And Cahill was a respected professor there. You don't get to Flinders University if you're if you're not smart. He submitted this paper to Nature. It's sad, didn't make it there. Gatekeepers. And Cahill has much nicer writing style. So let me see if he gets the Fresnel drag terms. It's looking like he does. I can't. I was hoping I'd see something I would recognize. The value of delta dt is deduced from analyzing the fringe shifts, and then the speed has been extracted using 13 instead of the correct form is 11. Refractive media. So this is the correction factor, and I don't see how that connects to the drag. Okay, so I think it'd be good to just review this, but I don't recognize the numbers. So, I'm sorry, this is like a nerd dumpster fire now. Oh, it's agonizing. Dmitriev's referencing other things too. See, he gets this delta t here, and it's a complex formula, and you compare it to Cahill, and Cahill's version is not quite as nasty looking. And this one here. So, but Dmitriev still references it, so let's look at Dmitriev. Where does Dmitriev reference Cahill? Cahill is number 11. Reference 11. 17. There's 5 here. Let's see if I can get to 11. Click. Nope. I want reference 11. 7. There it is. Therefore, the almost null shift of the interference fringe obtained in 7, 8, 10, 11 at plexiglass and presented without specification of the wave frequencies for the value n equals 1.49, and for the rays used in the interferometer of Shamir and Fox cannot be accepted as a demonstration of the negativity of the Michelson experiments at solid optical media. Rather, these experiments corroborate the discovered dependence XM. Okay, that's Demjanov's paper. Okay. And that's Cahill's. That's the Fresnel drag. And I'm about ready to quit because this is killing me. Whose paper is this? That's Demjanov. Okay. I have to kind of call it quits here. This is getting too hard to read. So, Sorry, guys. This is like what research is like. It's not pleasant, and some days you just end up confused. But thank you for getting me, guys. It was great hanging out with you all almost practically all day, doing streams and then other things. So, this is how it goes sometimes. Just bang your head against something and you don't understand, then you come back and the next day and keep trying until you can start to figure it out. So this is really a slow, painful process. So with that, glory and honor to our Lord and Savior Jesus Christ, who helps us bear these crosses, bear crosses to, bear these crosses, and doing creationist research is the cross to bear. And praise to Him to getting us through this, and hopefully each time we make attempts like this, we get closer to finding the truth. So praise to Him, and glory and honor to Jesus Christ. God bless you all. Thanks for watching. Take care, and God richly bless you.